What's up, everybody? We have 10 minutes here with Mr. Adam Maxwell to discuss direct impingement versus piston-operated semi-automatic firearms. Also, just learned that Mark might have trypophobia because he is slightly distressed. Slightly distressed by the 3 cameras on the back of his iPhone. Anyway, we'll get into that some other time. But Adam, so explain for those, direct impingement, piston-driven, all that stuff. Anybody not familiar yet, what is that? What are we discussing?
Well, first, I guess the part that I took an embarrassingly long amount of time to figure out, and if you're listening right now by yourself, you can just take this nugget and not tell anybody that you didn't know. But the actual gas pressure that cycles an AR-15 is in the barrel. Actually, all semi-automatic guns. The actual pressure that cycles the bolt is what's trapped in the barrel. Mm-hmm. And what we're talking about in this context is the gas pressure that it takes to unlock the bolt. So what comes through the gas tube on a DI gun or the piston is what gives it that initial catalyst to unlock the bolt so that the pressure in the barrel can cycle the bolt backwards.
Oh, so it's not actually the gas gas tube itself doesn't have the pressure that actually cycles it.
Yeah, so if you ever looked at a gas tube and were like, man, I can't believe that much gas comes through there to cycle that whole you're right.
So then what is it doing then?
So in a DI system, what you're doing, because you have a bolt carrier in battery, so it's locked. It goes into the extension, then it locks.
Right.
Mm-hmm.
When the bullet fires and goes down the barrel,
mm-hmm.
and it gets to this gas port, it pressurizes the tube and sends it back into the carrier, and then the gas seal is back here, and that's just enough gas pressure to make the bolt do this.
Okay.
Just kicks it out of battery. So it's like if you had, it's like
a jump starter.
It's like a dam on a river, and then all of a sudden you blew it up and all the water came rushing out, right?
Yeah.
The thing that broke the dam essentially is what we're trying to do. So it's just that little bit of push to get it started, and then once it's unlocked, the massive pressure that's in the barrel is enough to get the bolt traveling rearward.
Interesting. It's like a 2-stage system.
So that makes this whole DI versus piston thing seem even less of a big deal if that's not actually pushing the whole thing back.
Right. So that's a DI system. A piston system instead, now technically if you're, a super nerd on this stuff, there are both piston systems. So, but what's referred to as a piston system essentially is instead of diverting that gas pressure all the way back into the receiver, that transfer of energy happens at the gas block to a piston. That piston then transfers the energy back to the bolt. So that happens on a long stroke and a short stroke. There's 2 different kinds. A long stroke would be the most directly, conceptually the easiest to understand in that it has a carrier that goes all the way to the gas block, and that same amount of gas pressure to get it started just happens in the front of the rifle. Mm-hmm. And that energy transfers back through a steel rod to the bolt carrier, which causes it to unlock, and then the whole thing goes back.
Okay.
Same thing in an AK-47 or something like that, the more traditional gas piston designs.
Yeah. Same concept then as the DI. It's just that it's a steel rod making the initial jump or bump, so to speak, instead of gas.
Yeah, we're mechanically transferring that energy back instead of piping it back into the receiver. And then a short stroke piston works on the same principle, but instead of having a long carrier, essentially it's like a Newton's cradle, like those things that sit on people's desks, that have if you Google it, you'll see it. But the thing with the hanging metal balls, and there's like 5 of them, and you pull one out and you let it, and the thing back and forth. Newton's cradle. Same thing happens on a short stroke system in that there's like a piston and a tappet in the front by the gas block. Mm-hmm. There's a transfer rod that's spring loaded, and that essentially impacts the bolt carrier, hits it. So you have kind of this kinetic or metallic transfer of energy because a couple things tap into each other, and that gets the rearward motion started.
Okay.
In a short stroke system. So where did all that come from? Essentially what we have is when the military first adopted the M4 Kind of like back in World War II when they adopted the M1 carbine. They kind of needed this smaller gun to give to people who weren't really in direct combat roles, but they were still in a dangerous place, so they should probably have a firearm. That's what the M4 was. When it started getting pushed into mainstream service, they started to find the shortcomings of what it was designed for. The M4 was designed as a support weapon. It wasn't designed as a suppressive fire, massive, high volume of use. So like when SOCOM started using it, they were putting it on a more aggressive firing schedule. They started to find some of the weak points. And so, namely, one of them was they started breaking bolts. So bolts are going to break, but they were doing it on a faster schedule than they wanted to. So when they started soliciting for a new gun, or what they wanted a gun to do differently, that was part of what they were going after. And so to handle a more aggressive firing schedule, one of the things they started doing was looking at piston systems. And then part of what sold the cleaner and lower maintenance and all that stuff was some clever marketing by some of those companies into things that weren't necessarily they sounded
questionable.
Better. They weren't questionable, but they were definitely sold to have more value than they actually did. It was perceived value. Perceived value is what I was looking for.
So
perhaps?
Because a lot of people were saying that the DI, what's happening is all that gas is going back down the gas tube, and then it's just spilling back into your chamber, or that area right up there above your magwell. The chamber. Yeah. So is making it all really dirty, whereas this piston system blocked all that gas from getting all the way back into your chamber. So they said, "Oh, it's so clean."
Right.
It's the same amount of soot. It's just in different places. Now, a piston gun will run cleaner in the receiver, where all the moving parts and the lubrication are, which lends itself better to a longer service interval.
Okay.
So a piston-driven system can run longer without periodic maintenance.
Okay.
Than a DI system can.
That does sound like an advantage.
It is an advantage. But it was somewhat misportrayed at the beginning of the early days of it. The other thing that really one of the cool guy things when it first came out and when the 416 was really getting advertised hard is like Navy SEALs when they do their diving stuff and they come out of the water like frogs and they shoot. Well, if your gas tube is full of water, your gas tube will explode when you shoot it.
That's good to know.
Good to know.
So they had to let that
drain
out.
I was just about to go diving with
Sounds
my
like
AR.
I've gotten lucky a few times.
Well, like when the Navy SEAls went to the 416, that was one of the reasons, is because they didn't need this gas system to drain out before the system was ready to use.
Okay.
So
what about heat? I've heard like a heat argument, like it's not getting as hot.
That was one of the interesting ones. I remember that one too. They would shoot like a full auto magazine and then they would light a match on the head of on the bolt of a M4.
Right.
And then they would shoot a full auto M or 416 and then they would like touch it with their finger. So yes, much less heat transfer into the receiver. But
does it matter?
Not really, but that's also where some of the componentry, like as the M4 evolved, they started using different profile of barrels and things like that as well that could take the heat better. There are companies that have designed enhanced bolt carrier groups since then too. So there's been other advancements in that kind of thing. But where the DI versus piston thing really starts to set itself apart or make a difference is, the DI is the original system. So what advantages does a piston system have? Piston starts to have an advantage when you shoot a lot of suppressed.
Yeah, okay, I was hoping you'd get to that.
Okay.
A lot of suppressed. So because we're keeping more of that soot out, that longer service interval carries over into suppressed. Now,
like you said, the soot's still in there. It's just in the barrel now, and it just gets burned out.
A little bit. You're still going to get soot back in the receiver. You're just going to get less.
Okay.
Because remember, it's not all coming through that gas tube. So, yes, there is a lot of back pressure in the barrel that is going to come back in. But like when we run our demos and stuff like that or our range days and we have them side by side, like the piston guns run longer.
Okay.
Okay.
Than the DI ones do. Or they start to have hiccups sooner.
Is one easier to clean than the other when it does get fouled?
Piston systems are much easier to clean because the parts that get dirty are easier to clean.
Okay.
The actual, because the
Like you said, there's more parts
yeah
back there, I guess.
yeah, it's getting pressurized inside the bolt carrier. So what gets carboned up is the back of the bolt head and all the things in your bolt carrier.
DI.
Yeah, in a DI. So those are all the little parts that you have to scrape and clean out in
We
here.
did that we had a 10-minute talk where Adrian came in and he cleaned off or something like that.
Yeah.
He did like bolt maintenance and he had to pull it all apart. You take those little gas rings off,
Yep.
all that stuff. Yeah.
Yep. Whereas in a piston system, this is what gets dirty, and you could probably just take a wire brush to that.
Oh,
like
yeah.
a wire
Gotcha.
reel,
It's
and
just
then it's good to go. This is
little
much
piece
easier
of
to
metal.
scrub out than this is.
I like that.
And this part doesn't really get that dirty. The other key advantage to piston systems is when we start doing really short guns. When we start shortening the barrel, let's say below 14 inches, because then the balance or the intricacies of getting the gas pressure, the lag time between when the bullet passes the gas port and leaving the barrel, and being able to basically all the dynamics that go into making the rifle cycle.
Okay.
As we
right.
shorten the barrel up, that gets more, there's less wiggle room in making it all work.
Okay.
So piston systems, because they don't require as much, I'll say require as much dwell time, or they don't have to pressurize the whole system, and then the pressure that they're getting at that point is higher, it's more volatile in a short barrel than it is if it's longer. So it's easier to get a short gun to cycle more reliably and to cycle better on a piston system than it is in a DI. It can be done
Okay.
both ways,
Yeah.
but pistons lend themselves better to the short applications and the suppressed applications more so than DI.
I like it. Okay. Cool.
But
What do you prefer to use?
I like the piston guns. I've been a big proponent of like the long stroke piston systems like PWS and things like that for quite a while. I like the extended service life or extended service interval. Like I said, the parts that get dirty are easier to clean. And I also just like the way that the gas pressure is managed in those particular systems. But I use both. I use
Gotcha.
both.
So you gave some pros to the piston. Let's just to recap. I'm trying to think. Main pros to the DI. Is it cheaper? I'd imagine a little bit less expensive.
Cheaper. Parts compatibility, like through different brands.
Right.
A piston system tends to be proprietary to that
Yeah.
manufacturer.
Okay.
So if you're a at home builder, or if you're mixing and matching parts to get that rifle just the way you want it, you're going to be looking at a DI system. They tend to be cheaper. They tend to be lighter too. That's the advantage to DI tends to be lighter because they don't have this mechanism on top.
It's
They
just
have
a lot more
thin
metal.
Yeah, it's a thin steel tube. It's a very thin steel tube instead of a transfer rod, which translates to a few ounces.
Gotcha.
And then the springs that are associated
And
with
it's
it.
a few ounces out front too, which
Yes.
is generally not
Yep.
the most
Yep.
nice place to get more weight.
Leverage definitely. You feel ounces on the front of the gun more than you feel ounces.
Like when I
on the back
picked
of
up a
the gun.
416, I felt that a little bit. Where it's
Yes.
like, oh, this thing's up. This is portly.
Yes.
Okay.
Absolutely.
All right. Right on. Well, there you have it. DI versus piston. One thing we also got to talk about is separate 10-minute talk for another time. We should talk about the different gas lengths and barrel lengths and all that in AR-15s.
Oh, yeah.
You got short, midi, rifle.
Oh, yeah.
They got long barrels, how people match up. You know, the 16 mid is like the classic new thing. Anyway, that's another 10-minute talk, I think, for another time, probably with Adam here. But cool. Thanks, everybody, for listening. If you have anything else that you want discussed about these firearms or, you know, anything else in 10 minutes or maybe 14 in this case.
Ish.
Let us know. And we'll catch you all next time. Thanks.
Bye.
Bye. That's very intriguing.
I like
didn't know all these things. I didn't know all these things. No, that's fine. You know, 4 minutes.
I'm glad you brought up that parts compatibility because that's one thing that I was reading before because I didn't know before this topic came up. But that's interesting. Like they direct impingement, like it sounds like it's like a standardized, like it's standard, like across the board. Maybe not. I don't know. But then the other one, like you said, is proprietary. Like, oh, if you
Standard-ish. Yeah, but like
X brand.
oh yeah, I've been building this thing, whatnot, for it, and I got this barrel and I got this receiver and I want to do it in this weird caliber, like, but I want to do it in a piston system. I'm like, You can't. It's like you pretty much have to buy what they make, or you're not going to do that.
I wouldn't know the 300 Wisdom AR. Then I would assume is a DI system.
Yeah, you're gonna have to
Yeah,
use
yours
the
is
DI
DI.
on that one.
Yeah, for sure.
Magnum DI.
Have we ever gotten that thing shooting yet?
Can you start calling me Magnum DI? You don't have to.
I will.
Magnum PI. God, Tom Selleck is glorious, man.
Right?
There, I said it. It's out there. That's a good show too.
No, you know what I like? I am going to call you Magnum DI. I didn't like it at first, but I had to sit on it for a couple
had a
seconds.
Ferrari.
I had to sit on it for a
You got a
couple
Ferrari,
seconds.
Jim.
We got to get that stupid thing shooting so you can take it out hunting this next fall.
I know. That'd be fun. I wonder, is it just a matter of finding the right load?
Could be that. Could be just. It sounded like Ryan found a couple of weird little quirkies about it. I don't remember what the story is on
This
that.
is actually a thing you built?
Oh no, this is a thing that we pieced together. We got like a DPMS lower and this like I don't remember who built it. It was right now off the top of my head, but it is literally a 300 Wisdom upper, and wow, it's a peculiar thing that
If you get
We
hit with
couldn't
it, you
quite-
wouldn't want to be hit
we
with it.
couldn't quite get it shooting how we wanted at all. But we might be able to.
Ryan, it sounded like he ferreted out a
Like
few
it wouldn't cycle, or it wasn't grouping
conspicuous.
It was like, what would it do?
It
seemed
just
like-
wasn't grouping well when
it
I
wasn't
shot
grouping well
I
at
mean, like
all.
at 100, like
well? Oh.
Yeah. So, yeah, Mucky thinks he's got maybe an idea of how to make it adequate.
we need to revisit this. It took a hiatus of.
It did. It took quite a long hiatus. But, yes. All right. Thanks, Adam.
Yeah.
Really cool.
This old Two-Face.